So this is going to be a video on combinations. So a combination is an arrangement of items in which the order does not matter. The formula is right here. So this first one is 5, choose 3. Would look like this here. It'll be 5 factorial over 3 factorial, and then 5 minus 3 factorial. So this would be 5 times 2, 5 times 4, times 3, times 2, times 1. And this is 3 times 2 times 1, and 2 times 1. So these will go away. 20 divided by 2, which is 10. You do the same thing for this row here. I'll go ahead and do this one because it's a different notation. So this would be 14 factorial over 5 factorial times 9 factorial. I gotta use my calculator. So 14 factorial divided by 5 factorial times 9 factorial is 2002. Okay, I made a mistake on this problem right here, so I'm going to redo this portion of the video and then insert it into the original. So this is asking a question about if you have a deck of cards and how many 5-card hands are all the cards the same color. Well, in a deck of cards, there's 13 of the same suit. So you're going to do 13, choose 5. Is 13 factorial over 5 factorial times 9 factorial. And I'm going to go ahead and get my calculator now. So 13 factorial divided by 5 factorial times, it should be 8, not 9. So 8 factorial is 1287. This should be an 8 right here. So there's 1,287 same same color cards in one suit. So in 4 suits, there would be 4 times 1287. So back to the calculator. Is 5,148. A student must answer 4 out of 6 essays. In how many different ways can the student select the question? Does the order matter? No. So what's the combinations? It's 6, choose 4. So you have 6 factorial over 4 factorial times 2 factorial. It'll be 6 times 5. Over 2, which is 15. And a basketball team consists of 2 centers, 5 forwards, and 4 guards. In how many ways can the coach select the starting lineup of 1 center, 2 forwards, and 2 guards? So since he has 2 centers and he's choosing 1, so 2, choose 1 times he has 5 forwards, and you can choose 2 of those. He has 4 guards. He's going to choose 2 guards. So this would be 2 factorial over 1 factorial times 1 factorial, and then 5 factorial over 2 factorial times 3 factorial, and times 4 factorial times 2 factorial times 2 factorial. So let me finish over here. So it would be 2 times 20 divided by 2, which is 10, and then 12 divided by 2 is 6, so 120. Right, so that fixes the mistake I made, and I'm going to insert this into the other video that I made, the original one. Ski's math class, find the number of ways Mrs. Schultzky can select a team of 3 students from the class to work on a group project. The team is to consist of 1 girl and 2 boys. So what we're going to do here is 14 You choose one of those. So 14 out of 14 girls, you're choosing one, and then you're going to multiply by out of 12 boys, you're going to choose two. So 14 choose one is 14 factorial over 1 factorial times 13 factorial. And this doesn't matter. I didn't need to do this because you're just going to choose. Yeah, the number of odd counts for girls is 14, and that's what that number is going to be here. But let's go ahead and do the math here. So 12 factorial times 2 factorial times 10 factorial. So like I said, this number right here is going to be 14. And then this one. So the 10 factorial is going to cancel. I get 11 times 12 divided by 2, which would be 6 times 11 would be 66. And then I need to do 14 times 66. Is 924. The basketball teams consist of 2 centers, 5 forwards, and 4 guards. And how many ways can the coach select the lineup? Let me see. Is that the same question as the previous one here? Two centers, 5 forwards, and 4 guards. One center, 2 forwards, and 2 guards. Yeah, this is the same as the previous one. So same as page 14. So this looks just when there are 14 juniors and 23 seniors in the service club. The club is to send 4 representatives to the state conference. How many different ways are there to select a group of 4 students to attend a conference? So here's 14 and 23 is 37. 37. So 37, choose 4. Over 4 factorial times 33 factorial. So 37 times 36. I was seeing if I could just compute this without the calculator input. You need the calculator. It's going to be a big number. So So 37 factorial divided by 4 factorial times 3 factorial. $66,045. If the members of the club decide to send 2 juniors and 2 seniors, so out of the juniors, it would be 14 choose 2. And then the seniors is 23 choose 2. So 14 factorial over 2 factorial times 12 factorial. And multiplying that times 23 factorial over 2 factorial times 21 factorial. So this would be 14 times 13 divided by 2. So it would be 7 times 13. And this would be 23 times 22 divided by 2. So 23 times 11. All right, so 7 times 13. So 7 times 13 times 23 times 11. $23,023. Let's go ahead and see if I did this calculation right in my head here. So so 14 factorial divided by 2 times 12 factorial. multiply that by 23 factorial over 2 factorial times 21 factorial. Yeah, I got the same number, 23,023. Okay, that's the video on combinations. I'm going to post that before week 5, part 2. Check for understanding. And it's going to be, it'll be difficult to make a video of each check for understanding without giving away the answer. So